Welcome to Ask and Learn.
Hello friends, in the figure, if you see, there is a planetary gas system. So the radius of gas A, B, C, D, radius of the gas A, B, C and D, each of 3 inch. I couldn't draw the diagram here, it is very difficult to draw. Radius of outer gas E is given 9 inch. It is known that gas A has constant angular velocity 150 rpm in clockwise direction and outer gas E is stationary, so omega E is given 0. We have to calculate acceleration of the truth of gas D with gas A and gas B. So we have to find the acceleration of truth of the gas D that is in contact with A and E. Let us start solving it. First we will do the velocity analysis. T is truth of gas D in contact with A. T we are assuming truth of gas D in contact to gas A and its tangential velocity is r into omega A. R is given 3 inch, so 3 into omega A inch per second. Since velocity of E gas is given 0, so E is instantaneous center of gas D. So velocity of the gas we can write 2r equating both, you will get, just a moment, equating both, three omega A is equal to 2 3 inch omega into T. So angular velocity of gas D will be half of angular velocity of gas A. Now velocity of D will be R into omega t. R is 3 inch, omega is omega A by 2. So you will get 1.5 omega A inch per second for a spider. Velocity of D is equal to 6 inch because length of the spider will be 6 inch. So 6 inch into angular velocity of spider, and velocity of D is 1.5 inch omega into A. So angular velocity of spider you will get 1 by 4th of angular velocity of A. Since angular speed of gas A is given 150 rpm or 150 upon 60 into 2 pi radian per second, that is 15.708 radian per second in clockwise direction. So angular speed of gas D will be half of omega A. So it becomes 7.854 radian per second in counterclockwise direction, and that of spider S 1/4 of omega A. So it will be 3.927 radian per second in clockwise direction. Now we will calculate acceleration. Acceleration analysis. First for spider, angular speed of spider is 3.927 radian per second in clockwise sense. Acceleration of D will be AD into omega square S. AD is of 6 inch and omega is 3.927 radian per second whole square. So it would be 92.53 inch per second square. In this direction you can see gear A, this is gear D. So this is the acceleration of D, and this distance is 6 inch. No. We have to solve for gear D. Here we are drawing only the front view. This is center of gear. Its acceleration is in this direction. It is rotating in this direction. Tangential acceleration will be in this direction. This is E point. So this is plane motion only. Translatory motion with D. This is rotation about D. So tooth T contact with gear A, you may write acceleration of D, acceleration of A, acceleration of T with respect to D. So it would be 95.53 already we have calculated in this direction. Dt into omega d square in this direction. So acceleration of tooth T in contact to gear A, you may write this value already we have written. Here I have not written the unit inch per second square. This value O dt, this is D. So dt is 3 inch into 7.854 whole square inch per second square. So on solving it, it would be so this is the one of the answer of this problem. Now we have to Find the tooth in contact with gear A. B part. Tooth E in contact to you may write acceleration of E with acceleration of D, acceleration of E with respect to D, it will be ED into omega square D in this direction. Substitute the value. This is 92.53 inch per second square. ED is of 3 inch or omega D 7.854. So on solving it, acceleration of tooth E, you will get 277.6 inch per second square. So this is the answer of B part of this problem. Thanks for watching it.